Hello everyone, welcome to this session on strain energy problem. And previous problem we had solved for a beam. So first one was a cantilever beam. Next two problems were related to the simply supported beam subjected to a point load. Now will be a problem which will be related to a portal frame and which has been subjected to a load at one particular end. So whatever the problem we are going to solve here are all determinate structures. Now, determinate structure means which I will be able to solve by using equations of equilibrium. Now to begin to read out the statement and then proceed what we need to determine. We shall first read the statement of the problem. So we have a portal frame ABCD. So this is what is the portal frame. Portal frame means it is a structure in the form of a frame. So which is A, B, C and D. So it has an end A has hinged. So this is an hinge support. As it has been mentioned as hinge support, there will be two reaction component that will be arising at point A. And at end A is hinged while the end D is placed on the roller. So this is the roller support. So if we happen to show the reaction component, it will be having a vertical reaction VD and here will be having a vertical reaction VA and HA. Now to show the direction of HA is all dependent upon what direction the external force has been applied. Now as the external force is applied towards the right hand side, the resistance force will be towards the left hand side. So it is like simple way. If all the forces are downwards, the reaction will be assumed to be acting in the upward direction because it's a resistive force again to not to allow the structure to have any degree of freedom, that is any degree of movement. So this will be a horizontal reaction component HA and vertical reaction component VA and VD. As it is a roller support at D, it will be having only one reaction component at D. A horizontal force is applied on at the end A as shown in figure. So this is a diagram. Determine the horizontal moment at D. Assume all the members have the same flexural rigidity. That means EI value is assumed to be constant throughout. So EI value is same. So to start with the solution here, first we need to find out the reaction component at A and reaction component at D. To find out the reaction component, as it is a determinate structure, take summation Fy is equal to 0. VA plus VD will be equals to 0 because there is no any vertical force. So VA plus VD will be equated to 0. Then consider summation Fx is equal to 0. If we consider summation Fx is equal to 0, minus of HA because it is towards the left hand side, plus of P is equal to 0. So HA will be equals to P. So this value of HA is equated to P. Then you consider moment with respect to A is equal to 0. If we consider moment with respect to A is equal to 0, with reference to A, VD shall rotate in anticlockwise direction minus of VD into B. Then P with reference to A shall not be rotated because it is in line with point A. So as a resultant, P will not have any perpendicular distance with reference to point A. So P will not rotate. So VD will be 0. As VD is 0, so VA will also be equated to 0. So all particular reactions shall come out as 0 itself. Now what we have, only one reaction component is HA, which is towards the left hand side. Why it is towards the left hand side? Because the applied force is towards the right hand side. Resistive force will be towards the left hand side. So HA will be equated to P. So we need to find out the moment values and its limits of integration. So what we will be doing here by strain energy method is we will be equating the external work done as a half P into delta is equal to integration m square dx divided by 2EI. So what is this m square dx? That is external work done is equal to strain energy stored in the members. So we are going to equate the strain energy stored. Now this m is calculated for all the three members now. All the three members are AB, BC and CD. We shall calculate all the strain energy stored for all the three members. To find out that, first we need to draw the free body diagram. To draw the free body diagram, this is the diagram and with a reaction component which is already been calculated. So after drawing the free body diagram, the diagram will be represented like this. So P is applied on towards the right hand side. Reaction component P will be towards the left hand side. And vertical component force, that is the VA and VD, will be 0. As V and VD are 0, so obviously the reaction component here will be downward direction, here will be in the downward direction. Both these particular components will be 0. As this is towards the left hand side, resistive force will be towards the right hand side. Then again, resistive force here will be towards the left hand side. Reason behind that is, this is joint B, which is common to both, and net force in the joint B has to be 0. Joint B is common to for AB and BC. So as joint B is common to AB and BC, the net force in the member B has to be 0. So horizontal force component B is 0. Likewise, vertical force component, anyway the value is 0 here, it will be nullified. As this force is towards the left hand side, this reaction component force will be towards the right hand side. If it is towards the right hand side here, this force should be towards the left hand side, because net force at C has to be 0, net force at B has to be 0. Next is, the force here component will be upward and here it will be downward. Upward here and this will be in the downward direction. But here the net force of these forces will be 0. So we need not have to worry about the magnitude of the force. Now what is the concern here is, as this is P, this force component shall also be P. This force component shall also be P. Likewise, this is P here. Apart from that, as this rotates in, as the force is towards the left hand side, which indicates portal frame shall rotate in clockwise direction, resistive force will be in the anti-clockwise direction at point B, because moment also has to be 0, so as to form the equilibrium. Likewise, if this is in anti-clockwise direction, to nullify the net moment at B, this has to be in the clockwise direction. Then what should be the magnitude of this particular moment? Magnitude of the moment will be, as P proceeds along the upward direction, it will be P into Y. When it is Y is here, when it is at point A, it will be 0. When it reaches at B, Y value would be H. So which indicates moment value would be P into H. Similarly, moment value would be P into H. As it is in the clockwise direction, resistance force here it should be in the anti-clockwise direction, and the magnitude will remain same as P into H, so that the net rotation in the beam has to be 0. If this is in anti-clockwise direction, again rotation has to be in the clockwise direction as P into H. So these are nothing but the moment values that we are supposed to consider now. Now if I write down the strain energy, so moment value in the member AB will be, that is strain energy, I shall call it as strain energy, will be for the member m square dx divided by 2EI is nothing but the strain energy. So we shall calculate independently for AB, BC and CD. If I calculate strain energy for the member AB, so it will be called as internal strain energy for the member AB. It will be, so if I consider AB, that is nothing but the vertical member, with reference to A, this shall rotate in clockwise direction, and M value would be P into Y whole square dy, because it varies along the y direction, dy divided by 2EI. Now here limits of integration will be 0 to, limits of integration will be 0 to H. So limits of integration will be 0 to H. This is for AB. Similarly for BC, SBC internal strain energy will be, as it varies along the horizontal direction. Here horizontal force shall not rotate. Vertical force will rotate, but since the magnitude of the vertical force is 0, we shall not be considering the moment caused because of the vertical force. Whereas the rotation force is in clockwise direction, and magnitude of the rotational force is P into H. So P into H square dx divided by 2EI. So this is what is the value of the moment along the horizontal member, which is nothing but BC. Now what direction this particular value will vary? It will vary from 0 to B, because it varies along the horizontal direction. So it will vary from 0 to B. Likewise, consider the third vertical member, which is nothing but the member CD. So it is SCD, which is equal to integration m square d. So when we proceed in the downward direction, there will be two terms that shall come into picture. one term is nothing but P, and other term is nothing but the moment that shall come into picture. So P shall vary. It will rotate in the anticlockwise direction. When it moves in the downward direction, it will rotate in the anticlockwise direction, minus P into Y. Then this is in the clockwise direction, plus P into H, the whole square dx divided by 2ei. Now the limits of integration here is again 0 to h. We need to expand this particular bracket and then reframe the equation. So total strain energy would be strain energy in the member AB, strain energy in the member AB, strain energy in the member BC, and strain energy in the member CD. So there will be totally 3 strain energy that we are going to consider. And if we substitute all this particular term and then check out. First strain energy is integration 0 to h P the whole square dy divided by 2ei. This is for AB. Then plus the strain energy for the second member. Strain energy for the second member would be P into h the whole square dx divided by 2ei. So this is P into h the whole square dx divided by 2ei. P into h the whole square dx divided by 2ei, 0 to b. Then plus of 0 to h, the last element is this particular element. As it rotates in anticlockwise direction, minus P into h, minus Py plus of Ph. So minus of Py plus of Ph whole square dx divided by 2ei. Now the other two terms, there is no complication. We shall directly, we have the freedom to integrate. So which will be P square divided by 2ei taken outside. Inside the integration term, it will be integration y square dy 0 to h plus of 0 to b P square divided by 2ei integrate h square dx. So h square is also constant here. So we cannot integrate here. So we shall keep this as it is. Then the last term, which is the most important term, 0 to h. Here it will be P square y square plus P square h square. Then minus of 2, P into P will become y square yh. So this will be the third term what we have, dx divided by 2ei. Now we shall substitute the value of limits of integration after the integration term. So first term, when I consider here P square divided by 2ei as it is, integration of y square will be y cube by 3 0 to h plus of P square. As h square cannot be integrated, you can take it outside, P square divided by 2ei. Then what we left out is 0 to b integration dx as it is, keep it. Then this here, after this particular part, 0 to h P square, you can take it outside. Everywhere P square is common. It's integration y square plus of, here also h square. This will be integration h square dx. Then this here, it will be 2 integration yh divided by 2ei. So when we solve this will be, first term will be P square h cube by 3, h cube by 2 into 3, P square h cube divided by 6ei. Then the second term, here it will be x here. And when we integrate dx, this will be P square h divided by 2ei. It will be x, integration of x will be, this will be integration of dx will be x, 0 to b. Then this term here, P, integration of y square will be y cube by 3, 0 to h. Then integration of h square shall not yield any value. So this will be P h square as it is. Then divide, here you can consider divided by 2ei. Here also you can consider this is denominator, divided by 2ei. Now when I integrate this will be y square. But what will happen is, I am going to substitute 0 to b as the limits of integration. First, when I substitute, there is no problem. When I substitute the second term, it will come out as 0. So as a resultant, the last term should come out as 0. So the solution for this will be, here also I have a ph square, and here also I will be having p square h cube. Here also I have p square h cube, that is integration of this. When I take this part, there will be two terms here, p square h cube divided by 6ci, p square h cube divided by 6ci. So I shall write it as 2 times p square h cube divided by 6ei as the first term, because first value is p square h cube divided by 6ei. Similarly, p square h cube divided by 6ei. So it shall be kept as 2 times p square h cube divided by 6ei. Then the second term. The second term is this particular part after the substitution, which will be p square h square, because this is two terms, so h square is taken outside, and after substitution this will be b minus of 0, so I will be getting it as only b divided by 2ei. So what we can do here is, we can take out the common term here. Considering the common term will be p square h square divided by 6ci, because p square h square divided by 6ci, if I take out common here, so what is left out here is, because this will be 2 ones or 2 threes, if I take 6ci, that is nothing but the LCM, that is in the denominator, what is left out in the numerator will be 2h plus 3b. This is what is the strain energy, total strain energy stored in the element. This total strain energy stored in the element will be equated to the external work done. And then what is external work done? External work done is half P into delta. Now this delta, what we are going to calculate is the horizontal delta, that is horizontal displacement, which will be half P into delta H is equal to, this particular strain energy will be equated here, P square H square divided by 6ei, then 2h plus 3b. This we are going to calculate, because 2 into 3 will become 6. Then here it will be remaining 6 divided by 3, which shall come as 2. Then 6 divided, that is nothing but here we shall be getting it as 2, that is cross multiply. This 3 will come here and this 2 will go here. So 2h plus 3b divided by 6 is taken outside. So that is the reason why this particular term will remain as it is. Now what we shall get here is p on the left hand side and p on the right hand side gets cancelled. 2 ones are 2 threes. So what will result here is 2 ones are 2 threes. What will result here is the horizontal displacement delta H is equal to ph square divided by 3ei in the bracket 2h plus 3b. So this is what is the horizontal displacement that we are going to get after the substitution of the limits, that is ph square divided by 3ei 2h plus 3b. This is what is horizontal displacement that we are supposed to calculate. That means since it is roller support, it is free to move along the horizontal direction, and how much it will move after being subjected to the force P is all dependent upon the magnitude of the force P and what shall be the height of this particular frame, because high magnitude, as the height goes on increasing, the slenderness will increase and the displacement will also go on increasing. So this is what is the value of displacement, that is the horizontal displacement for the element when it has been subjected to the force P along the x direction. So this is the solution for the portal frame by strain energy method. Thank you. Have a nice day.